Thank you all for taking your seats. Sorry about the slight delay on the start. The technology didn't work, even though we practiced yesterday with our new laptop. Didn't work today. So anyway, it's working now, so I can de-stress a bit. So if I'm a bit anxious, I do apologise. Welcome everyone. Those who don't know me, my name's John Flynn. I'm the current chair of the Brisbane Committee for the Council on Tall Buildings and Urban Habitat Australia. And on behalf of our committee and our sponsor today, Bornhorst and Ward, it's my pleasure to welcome you all here to our third breakfast seminar for this year. And those who have been before realise this year we're talking about the changing face of Brisbane. And today we've got probably one of the biggest changing or tallest changes to the face of Brisbane in the Brisbane Skytower. It's a great opportunity to learn a bit more about this project. We've got a group of 3 speakers who will be presenting that project to us today. We have our first speaker is going to be Noel Robinson from NRA Collaborative, and Noel emailed me yesterday saying he'd lost his voice, so he's going to try today to do it. It sounds like he can, but he's got a 2IC he's going to jump in if his voice drops out. We've got Richard Cass from Bonacci's talking about the structure, and Brandon Kaiser, Kissicker, I'll get that right one day, talking about the facade. So I'll introduce those guys formally just before for their presentation. But events like today aren't possible without our sponsors, and as I mentioned, Bornhorst and Ward are our sponsor for today. And Bornhorst and Ward are acutely aware that engineering excellence alone doesn't necessarily drive the best outcomes. They believe it's the skills plus the focus on relationships that drive those outcomes. Bornhorst and Ward strive to improve not only the end result, but the client's experience through the process. Relationships like that are at the heart of their business. They invest in their team, ensuring that they're up to date with best practice, emerging technology, all set to add value to a project. Their focus on engineering excellence and proactive consulting has ensured their business has survived since 1965. We've got Brett Taylor coming up after the presentation of the vote of thanks. Could you please all thank Bornhorst and Ward for their generous support. Format for today's breakfast is slightly behind, but as usually, I'll do a little story about what's been happening around the world of tall buildings. Sit down, you get to enjoy your breakfast. About 5 to 8, I'll be back up to introduce our speakers and have you out the door by 5 to 9 to get back to work for a 9 o'clock start. So in terms of news, I guess our next seminar is here on the 1st of September, and we're just changing the topic at the moment, so I can't tell you what it's going to be, but it's going to be exciting. So please come along to that. As usual, there's membership to the Council on Tall Buildings and Urban Habitat is available online for $150 US. For that investment, you get access to the Council's weekly newsletter, monthly video lectures, and the database on the website. So things that caught my eye this month on the website was this was the 5th fire in Dubai since 2012, and a facade fire. Jose, who's on our committee, flew off on Monday to be an expert over there reviewing what happened. But this was a 75-storey building. The fire started on the 35th floor and spread most of the way up the tower. If you go on the database, you can actually click on the videos. You can see the facade cladding falling off and floating down to the street. So very, very scary. What they're saying is in 2013 in Dubai, they changed their facade rules to be non-combustible. Back then they could be combustible. And obviously the challenge here is generally these fires are starting from air conditioners on the balcony, they're saying, and spreading either through the cladding or through the insulation behind the cladding. So it's going to be interesting to see how the rules change to sort of stop those in these super tall buildings. But 5th in a row, 5th in sort of less than 5 years is quite a scary statistic. I think, remember, we spoke a couple of months ago about the Melbourne audit of the buildings that had this non-compliant cladding installed. So I guess it's a story that we'll see more of unfolding as these buildings start to try and solve the problems. And Jose tells us the external sprinklers aren't the answer. You won't put the fire out. The other building that caught my eye in Dubai is not really a building, but the tallest Ferris wheel in the world at 210 metres. We've seen this drawing around for quite a while, but what I spotted was this image here, where it's actually under construction, and the scale of this thing doesn't really portray in this image until you look at this picture here, and you see a guy standing at the bottom here. This is the spindle. It's 40 metres long and 20 metres tall and weighs 1,805 tonnes. It's a massive bit of steel. And these 2 cranes that are putting it up, again, the scale of those, 180 metre reach mobile crane. That's how they actually get it up, I'm not quite sure, but they can lift 3,000 tonnes each. So this wheel actually, when it gets to its full 210 metres, there's 92 cables holding that wheel in place. So there's a bit of load in all of that. Timber buildings are a hot topic at the moment. The next 2 have popped off the website. This one is coming out of Amsterdam. there's a bit of a race in Amsterdam. There's 2 buildings going up at the moment. The developers here say they think they're going to be the tallest timber frame building in the Netherlands, but there's another one that's going to possibly could beat them. So whoever gets built first will be able to claim that title for a small section. But the drivers, I guess, for these sort of projects, they're saying this will pull out 3 million kilos of carbon dioxide will be stored in the timber structure of the building alone. And they're chasing all the good things, waste purification, energy generating facade on the apartment building, and it's going to be interesting to see what happens. At exactly the same time, this building in that's a picture of the building. The other thing I noticed, I should say Arups are the engineers, but when you look at the timber frame building, it's got some massive cantilevers as it goes up, so it's good to see that timber can actually do some quite interesting engineering feats. This one is by Shinjiro Ban, the Japanese architect in Toronto. Again, this building is claiming it will be the tallest timber structure in the world, but they won't say how many stories at the moment. So there's obviously a race going on around the world with developers and engineers to develop the tallest timber building. The interesting part to remember is that still currently the world's tallest timber structure is in Melbourne at 10 stories, the Lend-Lease development. So at the moment, Australia is leading the race and the rest of the world is chasing. And we're trying to put together a presentation for later in the year on timber buildings in Australia. There seems to be quite a momentum in terms of people being interested in trying to develop that technology here, and new timber plants coming online shortly. In terms of what's happening in Australia, the Zaha Hadid's, or possibly first Australian building to get built, got approved by the Melbourne planning authorities this month. So we hopefully will see that start to evolve. And it's again one of those buildings in Melbourne that pushed the boundaries of plot ratios and things while the regulations were changing. And obviously the local authorities have approved it, and hopefully we'll see it built. But if you recall, it's all about these series of vases. They describe it as stepping up to sort of change the scale of the building and blend it in at the ground plane. In trying to find something that's happening in Brisbane, there was not a lot of news on the council website except for Brisbane Quarter, which we've all seen been under construction for a while. They dug that huge hole in the basement's now coming up, but they've actually officially launched the sales this month of we're looking for tenants for the office building. The hotel is obviously got an operator. When this is complete, there's about 48,000 metres of space in the commercial and residential, commercial and retail components, and an 82-storey residential tower. So not going to pip our story today. The other quick reminder is, there's the ground floor plan coming off George Street, I understand. The council conference in Shanghai, the Free City tour is fast approaching in November this year. So if you haven't got your ticket now, you should get it. I think it's almost sold out, but I know 2 of our committee members are going across, and they're all very interested in how a conference moves from 3 cities in 4 days. So quite an interesting journey through China. So if you want to see more of that sort of news, you just need to sign up and become a member, and you can access the hundreds of articles that are accessed on the database. All right, we're a little bit behind time, but I'll let you have breakfast now, and then we'll be back at about 8 o'clock to kick off the formalities. Thanks. To get things off, I'd just like to introduce our three speakers, and then I'll jump up in turn. Noel Robinson probably doesn't need an introduction to this room, but Noel is a well-known Brisbane architect, been in private practice for over 40 years. Over that period, his practice has secured over 60 awards. In addition to notable Australian buildings, he has designed buildings in urban places in 8 different continents, not a bad achievement. Noel's head office is in Brisbane at the moment, with offices in Melbourne, Sydney and Hong Kong. Noel Robinson is an adjunct professor at the Queensland University of Technology. He also chairs the Independent Design Panel for Brisbane City Council and is a board member of the Lord Mayor's Future Brisbane Board. And Noel also chairs the Urban Design Advisory Panel for the Sunshine Coast City Council, so a very busy architect. I think who's going second, Richard? Or Richard Cass from Bonacci's going second. Richard is a chartered professional engineer in New Zealand, we won't hold that against him, and a technical director of Bonacci Group in Sydney. He specialises in the structural design of high-rise building, and his projects include 3 of our tallest buildings in Brisbane, I understand. Brandon Kissiker is from Inhabit Group. Over the past 15 years, Brandon has gained a breadth of experience in facade and structural engineering, documentation and quality inspections. He's a certified facade and structural engineer and has delivered buildings in Australia, the UK and Central America. His approach to projects is a holistic view that allows the development of efficient, practical designs that integrate with architecture, structural design and building physics principles. I think Brendan will be the third speaker, so I'd love to invite Noel up to the stage now. And I think I need to...
Okay. Thank you, John. Here we go. I didn't have a voice yesterday, so we'll just see how far we get today. Good morning, everyone. Thank you for the invitation to speak this morning on the Brisbane Skytower, the latest addition to Brisbane CBD. A major tower like this doesn't come along every day, so it was an exciting opportunity for us to be involved. As you know, developing real estate assets is about timing and cycles, and I think that this project has met the market with impeccable timing. Delivering tall buildings requires not only specialised design skill and experience, but also a clear understanding of what drives demand and where buyers are likely to come from and what they are looking for. We're going to show you a little video first. Those marketing guys make it look really good, don't they? As we know, skyscrapers require substantial capital, and to minimise holding costs, they need to be designed for staged settlements. As a result, Brisbane Skytower consists of a series of vertical buildings containing 1,135 apartments, approximately 1,874 square metres of retail and commercial space as well, 697 residential car parks, in addition to Go-Get Share and electric car products. The total gross floor area of the project is approximately 120,400 square metres. Total height of the building is 270.3 metres above street level and 274 metres AHT. The population within the building will be in the order of between 2,000 to 3,000 people. It's nearly the size of a little town, isn't it? So, as you're aware, this site has had a long gestation period, going back to 2006, when the idea of Vision was proposed by Oscorp. That was a 72-storey tower, and that's it over there on the left. The Vision project started construction in September 2007, and by December 2008, the basement had been substantially excavated. Then guess what happened? Global financial crisis hit. Subsequently, the site was marketed for sale, and ultimately, Bill Burgee with AMP were the purchasers of the site in 2010. For those of you who may not know Bill Burgee is a major developer mainly operating in the western suburbs of Sydney. They are very experienced and knowledgeable with the delivery of major residential projects. They have applied this skill throughout the design process of Brisbane Skytower, carefully value managing the NSA's efficiencies and the operational costs. Bill Berger with AMP conceptualised a very different project vision. That proposal consisted of a mixed-use 92-level hotel and residential tower facing Margaret Street and a 36-storey, 45,000-metre office building facing Mary Street. The Mary Street site was subsequently found to be unfeasible in the current office cycle and was subsequently sold off. That site will become the new Mary Lane Western Hotel branded apartments project, and that's now under construction. That project is now joined at its basements with Brisbane Skytower through horizontal volumetric titles, quite a complex set of volumetrics. With the Mary Street site being sold, this gave Bill Berger and AMP the opportunity to build a single-use tower on Margaret Street to meet the evolving strong residential demand in Brisbane. By this time, 8 basement levels of car park had been constructed, including footings and columns for both towers. The footings to the core of the Margaret Street tower, however, had not been poured at this stage, and the excavation of the core was back to bare rock. This gave us one of the greatest opportunities to get a very efficient core. Everything above Margaret Street level is new and was designed by our firm, which took into account the existing Bates Smart design basement structure, which allowed us to also reconfigure and reorganise a highly efficient core for the residential tower. The tower plan shape was informed by the already built substructure, and as such it proved to be extremely efficient aerodynamic shape. Richard Cass will explain that this plan shape, together with the curved corners of the triangle, have low resistance to vortex shedding and that reduce lateral wind pressures, and therefore the sway of the building is minimised. In this case, the building was refined during the design process so that we eliminated the need for mass damper tanks at the top of the building, thus enabling additional valuable floor space to be released and sold on the upper levels. Brisbane Skytower has commenced construction and is now at level 6 above ground. Now that the typical floor is evolving above podium, the pour cycle times per floor will be around 10 days, so the tower will rise reasonably quickly from here on. Hutchinson's are building Brisbane Skytower and Watpac are building the Mary Lane project, with the preference by both owners not to have the same builder on doing both projects. So, as you can see there, the developing in stages to be sold. What's the next one? To the building breakdown, we now have on the podium levels, with the ground floor and the podium consist of individually zoned lobbies for each of the building towers. We have on the ground floor the downtown, the uptown, Sky City and Skyrise at penthouse lobbies. And also additionally we have retail space on the ground, plus on the first level on the podium we have an office and a health club. The low rise, 1 or 2 bedroom apartments mixed for these two parts. The downtown apartments up to level 16 and uptown apartments followed by their residents, recreation deck, pool and gym on level 40 and 41. The mid-rise apartments consist of 1, 2 and 3 bedroom apartments. Mid-rise is serviced and accessed by recreational decks, pools and gym on levels 66 and 67, and able to access recreation from 40 and 41. With the high-rise apartments again consist of 1, 2 and 3 bedroom apartments. They go up to level 81, and above these levels are followed by sub-penthouses and 2-storey apartments and are a number of penthouses. The penthouse on level 88 consists of 2/3 of one entire tower footprint with its own private access to viewing terrace on level 90. Also on level 90 is the infinity pool, a large entertainment recreation deck and gymnasium for the skyrise and penthouse residents, exclusive use. This slide provides more detailed configuration of the mix of the building. The lobby, Brisbane Skytower on the ground plane has a generous 6-star residential lobby for the skyrise, as well as separate lobbies for downtown, uptown and Sky City. The ground plane also contains specialty retail outlets that connect through to Mary Lane retail cross-site link. This site is a major benefit to the pedestrian circulation within the CBD and was achieved through town planning requirements for a cross-site link that was set in place many years ago by the Brisbane City Council. The apartment mix, the apartment has proven very popular with high-level sales to both Australian and Asian buyers. The design has generated a mix of apartment sizes and bedroom types. There is 40% one-bedroom apartments, there's 50% two-bedroom apartments and 10% three-bedroom apartments. Overall, 1,135 apartments in total. An attraction to many of these purchases is the iconic nature of the tower, as well as the panoramic views that will be achieved from the building, which of course will be spectacular. Recreation spaces have been tailored to each of the building rises. The health and spa facility is located on level 3, thus has been designed not only for the use of residents, but also for external membership. This contains a 25-metre lap pool, health and spa, club and massage, jacuzzi and gymnasium. This facility is not under the body corporate control, which means the body corporate fees for others using the building or owning the building are reduced by not having this facility as a burden, but as a profit centre for the developer. The most spectacular one of is the infinity pool at roof level, which will feature Australia's highest infinity edge swimming pool. This pool is for the exclusive use of the upper level penthouses. And I see last night on the web that Luca and the Gold Coast is going to be claiming the world's highest infinity pool. And I think we'll probably have that title till they're built. 2 recreation facilities occur at level 40 and 60. These include an infinity pool, gymnasium and outdoor recreation. The car park, quite a complex piece of work. The car park construction was substantially completed in 2014 and comprises of 8 levels of basement car park and a total of 920 cars. A major part of that car park facilities that service Brisbane Skytower, basements 4 to 8, are now being operated as a temporary public car park with 714 car spaces. This part is being accessed from Margaret Street. The existing car park for Brisbane Skytower development is located within the lower portion of the 8 basements, with 714 allocated to Skytower and the other 206 places allocated to the Mary Lane development. The car park is accessible from both driveways in Margaret Street and Mary Street. The Mary Street will have access to the Mary Lane project and its entrance. The lifts, there are in fact 18 elevators in this project, with notably a sizable goods elevator which runs the full height of the building. This is particularly advantageous for residents when they're moving in and out, as well as it has a firefighting advantage that access is gained to every floor level through one elevator, rising through the building from the base to the top. Elevators are super quick, with the speeds of various elevators servicing each building rise increasing from 3 metres a second for the downtown and uptown and up to 7 metres a second for the sky rise and penthouse levels. A bank of elevators serves each building rise independently. The only disconnect in the elevators is from level 82, which transfers to 2 executive levels at the top. And if you look at the diagram, the dark red is the areas that those particular elevators service. So they're direct service elevators. Now Richard's going to have a bit of a chat now.
Thanks, Tom.
Right, that's a half plan of the tower, the basement carries on the other end, and the Mary Street Hotel is currently being about to construct is on the other end. Now, sorry, excuse me for a minute. Here. Sorry about that, mate. We design high-rise buildings, and building high-rise buildings is inherently high risk, but not perhaps why you think. The reason they're high risk is not because they're tall, but because they take a long time to build. So because they take a long time to build, you're going to be exposing yourself to financial crises, GFC, natural disasters. We've got our Brisbane floods, market shifts, change from need for commercial, then it changed to residential, back to so on. We've got political changes. Governments can come in and out of power throughout the construction. External, China, their demand for coal drops off, has big financial impacts. And now they're the big risk factors for the design of the towers and for building the towers. Now, so it's likely you're probably going to run into one of those events when you're building a tower. However, this tower seemed to sort of collect a whole lot of them. It went through. It was a casualty of the GFC. It was then it got inundated by the floods. Then it was there was changes in the market demand, and so we end up with the structure that gets pushed around by all these external forces. At Bonacci, we have a bit of we follow the principles of trying to design simple buildings, and so they're simple, and we also design them to be built fast. So they're designed to be simple and designed to be built fast, and then we build them, and then the idea is to try and build them fast. Doesn't always work out that way, and this is one of those case in points. Just bring us on another slide here. So I'm going to take you through, first of all, I'll take you through the history of how this structure has been pushed around. So looking basically at this concept of trying to build a building simple, where if you have a clean sheet of paper, that luxury, you would come up with one design. In this case, you end up with a building that's really the response of a number of external factors, and it's definitely not a clean sheet of paper answer that you'd get at the end of the day. And I'll explain that through the history, and then we'll go through a bit of technical bits and pieces, because I think we've got quite a number of engineers in the audience that would be interested in that side of things. Okay, so we've got just a little bit of a view on this thing here. You can see we've got a triangular core in the middle. We've got big row of columns around the outside, and around the perimeter there, this is the basement line outside there, and we've got a sort of showing around the perimeter a few little structures that we had to do to try and modify the existing basement. Now, the first tower that was proposed was a 292-metre resi tower to replace the Vision. Sorry, the first tower, of course, was the Vision Tower that was built by Grocon. They built the basement, and see if we can get through. So you can see that first image there. That was where we took it on as a big duck pond. With you can see there the basement was full of water. So it's already been through the global GFC. Sat there for a while, filled up with water when it got hit by the natural floods, and this is when Bill Berger took it on, and this is where I came into the picture. So you can sort of see around the perimeter there, you can see the beginning of the basement. Now the trouble is it sat there for quite some time, and so the anchors that hold the shoring wall up, remember this it's 20 metres deep, it's 8 stories deep, and it starts, the anchors, the ground anchors start to rot after a while. They've only were intended to last 3 years. So if we drain that basement, we've got potentially problems where shoring walls could collapse in. So the first thing to do was, so we can't just drain the basement, but we also need to strengthen it. So put a barge in there, quite an ingenious solution. Went round, checked all the anchors, about half of them were failing, replaced all the ones that were failing, let the water out another story, go around again, check all the anchors, replace those ones that need to be replaced, and so we went down until we get to this next picture over here. And so there we go, drained basement, and you can see the, have I got a pointer?
Yeah, it's in the
Little red line.
Brilliant, okay. I'll stand over here. So here we go, this is the basement all excavated. Now just a few little pointers you can see on this. It's a D-wall, a diaphragm wall. For those of you who don't know what that is, it's you basically dig a trench around about, these ones are 6 metres long by about 600 mils wide. You fill it up with bentonite clay that holds the sides out to stop it collapsing, and then you replace that with concrete. So these big piers that make up the majority of the walls. Round here, we had there was a sensitive neighbour over this side, so these are actually secant walls. They're like drilled piers that go down, and these are big wailing beams that go across and stiffen it. So this is the basement that we inherited. That was the old foundation for the old Vision Tower. You can see it's a rectangular one. It had a single tower on the site there. And of course then Batesmart, on behalf of Bill Berger, came along and designed the original 2 towers, which was a triangular resi tower and a D-shaped commercial tower at the Mary Street end, which is the other end. Now, one of the things is like that tower there had been isolated from the basement, so it had to cantilever from right to the bottom, you see. Now, our philosophy is, well, we'll lock it into the basement at ground level, and what that means is that you end up with, instead of trying to design a tower that's got to go, in this case, 290, I think it was 288 metres, you actually design a tower that's going, another 20 metres on top of that, So the idea was we swing it off the top of the basement, but the basement's not designed to take horizontal load. So the first thing we have to go through and do is strengthen up the corners so we can take shear into the basement, and of course a number of other things, which is pretty minor stuff, which is really, I keep on doing that, sorry, there's one here I'm looking for, is to go through and dig a new hole for the new shaped core, do a bit of strengthening. None of the floor levels are going to be where those ones are, so we have to put new starters in the walls. A few other measures, strengthening up bits and pieces just because of different floor structures being different lateral loads imposed. Okay, so we've gone through a GFC, we've gone through a flood, we've inherited all those problems that are associated with that, and we've got our basement now excavated, strengthened up, and down in here is, so you can sort of see here's the excavation starting for the new residential tower, which was a triangular tower originally. Now we'll go back to here, and Noel did mention initially about the shape of the building. Now, a triangular tower is probably the worst shape for a tower. What it does is you get triangular towers have very high vortex shedding on the corners, on the sharp corners, and what that does is they're your primary sort of force that you've got to design for. It produces high forces on the building, and it also produces high accelerations. Has big implications on cost and how to build the building. So the first thing we did was ease the corners. So the triangular tower got softened to more a vapor drop shape, which was fairly similar in form, in plan shape to what we've got now, but not exactly the same. All right, so we've got a triangular tower going up, but now we've eased the corners as we've sort of got through a few rounds. And you can see at the other end, underway here, is the core for a commercial D-shaped tower that was going to go at the other end. That's the Mary Street end, which is now the hotel, of course. If you have a look up and, let's see, now we go to the next one over here. Now if you have a look in the corner, sorry the slides are a little small, we can't really see very well, but in the corner here, you'll see the beginning of strengthening the corners. We put in these walls that go inside the basement, and that's so the basement can carry shear, so the tower swings above ground level rather than have to cantilever from foundation level. Saves an anchor, saves in all sorts of things. Right, so here we go. So already the design's been pushed a little bit around because of the existing structure. Now you can see progress is, now progress raced ahead in this one here on the, rightly or wrongly, the decision was made to take off and speed up construction on the commercial end tower, and you can see that there's a number of floors. It's about B4 at that stage there, and you can see down in the bottom here, just scratched out for the triangular core. The columns are being built here, and this basement's coming up the other end. So the basement floors are coming up. Now, the next variation was going from the resi tower was to change. So from the resi tower, the next thing was, it looked like the market was shifting again. So another one of these external forces was changing the building, and so now there seemed to be more demand for a commercial tower than there is for a resi tower. Already got a commercial at one end, but Bill Berger wanted the option to be able to turn the resi tower into a commercial tower. The impact of that was it's a column shift, so the columns get moved to the outside. Commercial floors like a big floor plate, so we had to accommodate larger go right back to this one here. And if you have a look in here, you'll see these are massive columns. They're oversized. And the idea was that you could locate a column there or on the outside. So the columns could either go on one end of these rectangular columns or the other. So initially they were round columns in those days, so they could go in either position. And the other thing was they built the basement with a big hole in the floor, and you can see that line, that sort of curved line around the outside. That was to take the old core. All right, so they built a basement through here, the basements you can see under construction here. They've been built all the way up, and they've got a big hole in the floor all the way down, right down to the bottom. And you actually see, I might have a picture of, there we go. This is the hole, and you can see that all the basement floors have been built up. It's massive. And so there's a big hole there to take, obviously a commercial core is going to be a different shape, got a different lifting arrangement than would be required for a resi core. So there's the flexibility built in for the commercial core. There's also flexibility built in for the column position. So we can build turn this into a commercial tower or a resi tower as market forces dictate. And it wasn't until we got to about B1 in construction before that decision was actually made that we were going resi tower, and the market forces had changed that way. And of course that had an impact on the other end as well, where we've got this commercial tower then got converted into it was going to be a D-shaped commercial tower. It's now obviously, of course, it's a batwing-shaped hotel. And so you can see the market dropped right off for commercial towers. So we've got, it's all resi and hotel now. Now, the next thing, so Bill Berger had quite a bit of foresight in this respect. They like a simple building. So we try and design the building simply. But then also, Bill Berger had put up the brief to design a flexible building as well. And so that meant, obviously, there's this thing for the commercial tower resi option, which was a good call at the time. There's also they wanted flexibility in their resi mix. They weren't quite sure of the mix of apartments, so the apartment sort of layouts and so on change. It has a big impact on structure. So we had to sort of like, rather than take a punt one way or the other or what they were going to do, we actually put in 30% extra ground anchors. Remember, this building's 292 metres at the time. And so it needs to be anchored into the ground. So we actually put in ground anchors to meet those options. So in other words, we just sort of took a bit of a punt. Well, if it looks like this, we're going to put some extras here and some extras here. And so we put the ground anchors in to accommodate these options. So Bill Berger's call, building in more flexibility in the tower, in addition to this whole commercial one. Now the next iteration is now we get the brief that airports limit the height of the building. So the 274 metre height is a limit imposed by the airport. And so and of course, Harry Triggerboff before, the Meriton Towers had a go, and Bill Berger thought they'd have a go as well and see if they can get to 300 metres. So we actually went and put the provision in to design this tower for 300 metres. What that meant was a damper tank on top. I'll cover what that is in a minute for those who don't know. And we also, we're going to need extra anchors. Now, fortunately, there's some extra anchors in there. Now, those anchors, imagine we've got 23 meganewtons of anchors on that one, and we've got 10 over there and maybe 2 on that one. And they were all tailored for those other tower configurations at 274, depending on which way we went. But there's a surplus there. So the idea, what we did was we grabbed everything we've got and said, right, how do we make, if you just do a clean sheet of paper tower on top, you're going to get various tension reactions on the footings for that particular tower. So say you've got a clean sheet of paper, you want to put your outriggers at usual 2/5 height and 4/5 height and all those usual rules. We don't have that option. So what we do is we take the outriggers and we start moving them around, moving them up tower, down the tower, making them deeper, making them shallower, changing the size of the columns, all those big factors that will change the stiffness of the tower. And by changing the various parts of stiffness of the tower, we shift the forces around until we tailored it and we had 1 meganewton to spare. In other words, of absolutely dozens and dozens of anchors down there. We got it just over the line for a 300 metre tower, but with the constraint that the tower had to be this shape. And so I might just flick forward and hope I got that picture there. All right, so if you have a look at that one there, you'll see these are the outriggers, and those heights and so on were actually driven by this scenario, right? Now, as it turned out, they didn't get to 300 metres. It's 274 metres. Tower got trimmed down, ditched the damper tank off the top, and and the Outriggers, all we did was we were stuck with those. We can't move them around because the marketing drawings are already sold. So what we have to do is just go back and we could trim structure. So we just took it back until we got it as trim as we could and thinned up what we could. So we could take structure away, but that's a legacy of previous decisions. So where I'm going with all of this is that we start off with all these external markers, drivers, which aren't obvious, but they're the real challenges. If you give me a clean sheet of paper, that's a no-brainer. That's just textbook answers. But when you look at all the factors that start coming in and all these external influences and having to change and so on, and fortunately we had Bill Berger with the foresight to put flexibility to actually allow for flexibility in the structure and pour some money into those areas. And we also, once we got to the latest iterations, we had NRA on the team, which was fantastic because they're very builder-friendly architects and they know the importance of building a simple building. And so they rationalised a lot of the structure, simplified the columns, eased the corners on the floor plate, as Noel said, that helped on the wind loadings. So they did a lot of good things that made it easier to build and made the building work a little bit more efficiently to boot. So that brings us to the current day where we've got this tower. Now, I'll just go through a few of the factors. Now, that's a little extract out of the... sorry, I should have probably showed you the last of the pictures. Yeah, so sorry, just to recap on the last of the pictures. That one there, they've got it, that's actually the hotel end. They've got up to ground level. Down here is the beginnings of the Skytower foundation. That's the empty core. This one here is just the actual level ground there. And I think we're missing the final ones. Okay, so we're currently actually a couple of floors above ground. So, 10 years on, we've basically dug a hole and got to just above ground level at this point. All right, so let me go along a little bit about the structure. I mentioned a damper tank before. Now, let me just briefly explain. I'll be quite quick to get over the last. I'll just cover a few points. So, damper tanks. With tall buildings, we're more concerned about how they move than necessarily how much strength they have. They're sort of the driving criteria. That's differential shortening and acceleration. So if you've got a building that's swaying around, the people will feel unsafe if they're trying to sleep in the top apartment or might even feel sick. So we have to manage the acceleration. So the damper tanks are put in there just for that service condition of managing those accelerations. And what a damper tank is imagine the building's got a natural frequency, say, for example, about 7 seconds for this one. What you do is if you had a tank and it was the right length and the right dimensions, the water will slosh back and forth in the tank once every 7 seconds. So if you've got the volume of the water is, say, 1% of the modal mass of the building, then when the water sloshes, when the building sways this way, the water tends to slosh that way and it counteracts it. And so you've got this thing going on. So if you've put a tank of water that's 1% of your modal mass in there, you get 1% damping roughly in rough waters. Okay, so that's the damper tank, and it would have been we try and avoid them. Getting up around 300 metres, you're just at the realm of super tall, and you're probably going to need a damper tank at that sort of height. Obviously, we've dropped down. It makes a big difference. Just dropping 10 metres even negated the need for a damper tank. The other factor that's unique to high-rise is these are the Outrigger sets. Now, for those who don't know, here's the analogy. The core, which is this piece down here, the primary lift core. So this model here is our rivet model of structure. It's got the columns stripped off it in the floor plate so you can see the internal guts here. Now, the internal core is like my body, analogous to my body. The outriggers are like my arms, and the mega columns, which are not shown there, to which they're connected, would be the skiers' poles, for example. So imagine I'm here with my ski poles. You can imagine how stable and how much stiffer I am if I've got my arms out like this, take them in. Okay, so there's the whole concept of the outrigger and the damper tank, which is pretty much all there is to the building. The building's very simple. It's just a simple primary core, outrigger structures. That doesn't mean it's easy to design. There's an awful lot of engineering that goes behind it, but the end building is simple to build and fast to build. So at the end of the day, that's my that's sort of my advice to you is that you design a building that's simple and you design it so it can be built fast, and then you try and build it fast to avoid all these hiccups that are going to come along the way. But of course you can't, and you get one like this that collected the full gambit of them all. It got the global financial crash, it got the natural disaster, it got the market changes, it got the whole lot. We're just waiting for the famine and the water now, and we'll see how we cope with those two. Have we got any questions? Or should we include questions afterwards? Yep, okay, all right, cheers.
Okay, morning everyone. Probably got about 5 minutes or so to try to get through a lot of information, so I'll try to make it quick. Zen? Okay, so 31,000 square metres of curtain wall, 31,000 square metres of glass. That is a lot of glass for this building. We've pretty much got mostly curtain wall, traditional curtain wall facade, and window wall facade for some of the balconies in the sorry. Push the red light. Fantastic. Down here we've got some balcony areas here with window wall in there. The majority of the rest of the facade is curtain wall for the three risers, with some plant level and recreational deck facades in between. Average cost is around about $950 per square metre for the curtain wall, which is around about $30 million for, in total for the curtain wall package. The geometry of the facade, it's reasonably simple. Pretty much we've got 3 flat sides to the floor plate and 3 radius corners. 2 of them are 11.3 metre radius and the third is 14.1. The way we deal with that radius is by faceting the facade panels, and we handle the change in angle between the flat panels by adjusting the angle and adjusting the extrusions of each mullion. So this is a vertical aluminium frame as part of the unitised curtain wall, and what we're doing is adjusting the extrusion. So early on we looked at a couple of different options of possibilities of what we can do to try to deal with that. Vertical section through the facade, we've got a low sill down near the floor level here. We've got a high head and around about, I think it's around about 2300 of clear vision glazing. We've also got awning windows, so we'll have a transom through here somewhere and awning windows above for ventilation of the apartments. Down at floor level, we've got a recessed slab bracket into the concrete, as you can see on the right there. And for Class 2 buildings, you need to have fire separation and acoustic separation between levels. So I've got there in red highlighted the fire insulation, acoustic insulation, and also some vinyl wrap occurring down the bottom here to improve the acoustic insulation. Glass performance. It's generally pretty good glass performance. We've got a IGU for all of the vision glazing, IGU for some spandrel glazing, and single glazing for some of the spandrel as well. But for the IGUs, we're talking a solar heat gain coefficient, which is a measure of the solar energy coming through the glass, of 0.22, which is pretty good. We've got a blue and grey body tint, which helps to achieve that solar heat gain with a double stack low E, high performance. The body tint also helps to reduce the UV penetration, which helps with reducing fading of finishes, internal finishes. Less than 20% reflectivity, external reflectivity for the council requirements, which is typical. And we've stipulated an 8mm outer light to help with improved hail impact resistance. Standard is 6mm, which is generally cost efficient. With Bill Berger, we've requested 8mm, and that's what they're doing. So ESD, energy modelling. Energy modelling was carried out for each individual apartment, which is a requirement to the Queensland Development Code and BCA. We've got some NATA's assessment for each apartment, requiring a star rating. Generally the worst performing facade apartments, or the worst performing apartments, are the ones on the east and west elevation that cop the early morning sun and the afternoon sun. And they also happen to be the apartments that have got a high facade to floor area ratio, which means they're getting more sunlight for the same apartment if you've got a high proportion of glazing to the floor area, then you've got a worse performing facade because there's generally more sun coming in. Worse performing apartment. So what that means is generally for the Brisbane climate, you need a improved solar heat gain coefficient for your glazing, which is the level of sunlight coming into the building. On the right here is the facade subcontractors thermal modelling, which is required to BCA. They've gone through all of their different aluminium extrusions and arrangements to determine what the whole system performance is, which takes into account the glass and the framing performance. We're generally achieving a U value of around about 3.1. Wind pressure has been noted a couple of times. The rounded corners generally tends to reduce the cladding pressure on the glazing elements by around about 15%. There are still some high pockets of wind pressure, but overall generally you get a reduction because of the rounded corners. One of the key issues that on this building and a lot of other high-rise buildings throughout Australia, residential buildings throughout Australia, is awnings that are left open during storm events. So what can happen is if they're left open, you get build-up of internal pressures, which can be quite significant. And the internal walls and floors would need to be designed for higher internal pressures. So a way around that is to introduce some self-closing mechanisms for the awning windows. On this project, testing has been completed for the chosen method, and those awnings are tested and rated to close at 1500 pascals. So what that means is when you get 1500 pascals applied to the facade for an open awning, the awning will shut. There's a mechanism that holds it closed. So when a storm event occurs, you don't get the build-up of internal pressures. Performance testing has been carried out in China. There are a couple of leaks which were fixed up and the testing was passed. Cast and channel testing has been carried out. As I said, the self-closing mechanisms have been tested and we're currently reviewing the results for those. Another key element, this is a flush glaze system, so you don't have any mechanical capture of the glass. The glass is effectively held on with structural silicon. There has to be extensive testing and quality control for that silicon because we don't want to have an issue on so much glass for this job. We don't even want to have 1% of issues on this job. So we've actually got staff in our China offices that are going to be in the factories for 2 months straight, every day for 2 months, reviewing all of the testing, reviewing all of the facade panels and the fabrication to make sure that it's good quality. So on the right there, sorry, we've got the factory over in China. It's a new factory. It's a relatively new subcontractor. They've got 2 production lines. Generally, the big subcontractors like Uanda have got 14 production lines in their factories. This factory's got 2. They've got 2 projects that they're currently completing for Lendlease in Melbourne. I believe they're working on 300 George Street, and this will be occurring at a similar time. As I said, we've gone through full material review and inspection, and we'll also be in the factory inspecting all of the fabrication works. And lastly, installation of the facade panels is typical. It's just like a commercial building. The facade panel, these are some photos from 480 Queen Street. Facade panels are lifted into place from a few levels above, twisted around and lowered down to marry up with the adjacent facade panels and then fixed into place. One of the, I guess, odd things to solve on this project, where we've got the large perimeter columns and facade panels sitting in front. You can't actually get the crane into place on top because the column's going to be in the way. So what they're doing is installing the panels from hanging from the construction screens above. So they connect the panel to the construction screen and move it across and lower it in place instead of using the creepy crawly crane that you can see there. The installation would be about for one level, will be about 2 weeks to begin with, and then they'll ramp it up to completing one level every week, which will be around about 40 weeks in total for the 32 or 35 storey lower levels. And that's it from me. Hand you back to Noel.
I'll just take a couple of minutes to wrap up. Being a tall building, the external interface of the indoor-outdoor environment becomes a serious climatic design consideration. And having lived in Riparian Plaza for 10 years, I had some understanding what was required in terms of external environment. Riparian Plaza, in my opinion, is one of the best Seidler buildings ever. It's a wonderful vertical composition between base, middle and top, and uses sculptural elements to deal with the site and its environment. City sites have particular dynamics for comfortable living. Once you get above 30 stories, the wind becomes a challenge for a lot of the year and limits the amount of comfortable outdoor spaces that can be provided. At Riparian, I was fortunate to have a 60 square metre balcony facing northeast, which was great. However, it was only usable and comfortable for about 20% of the year due to the high winds and the supercells. Furthermore, the selection of furniture is a critical element to be considered in the uses of tall buildings, particularly when high winds hit sometimes with minimal notice. Furniture on balconies can become lethal objects in an instant, and when the doors are open, even things can be sucked out of your apartment, which they have been. The other thing that is important with living in tall buildings is dealing with the pollution and acoustics. For example, Riparian, subject to noise from the story bridge as well as airborne brake dust and rubber fragments and other emissions. And unless you've lived in the city centre, you think that Brisbane is absolutely clean. Well, I can tell you it's a million % better than anywhere else, but there still has a few problems. Of course, the acoustics is another issue, which is for CBD residents. Principle behind Brisbane Skytower is to deal with all those issues in a different way to Riparian and to internalise the environment, particularly above level 34 where the external balconies stop. We have designed Skytower into Skytower openable windows to the apartments. They have self-closing devices to seal the building beyond certain extreme conditions. And as you can imagine, a big building like this, and particularly with short notice, that having someone in these weather events, it would be a nightmare for the building manager to go around and inform everyone to close their windows. So the windows all have an automatic self-closing mechanism that activates under certain conditions. So even through the 3D images present this absolutely beautiful smooth skin, in any one day there will be lots and lots of windows open and opening on the facade. So this, to some degree, is going to change the character of the building daily in the skyline. Also, the external skin is glazed with low energy double glazing. This, of course, from the inside provides 100% maximum intake of the view with floor-to-ceiling glass while minimising the intake of heat and glare, as well as minimising noise transmission. The external skin is of a fine grain, subtly detailed, consisting of blue, grey and white panels, so the building will have its own patina when viewed from short and long distances. During the daytime, the building will have and change colour shades and will reflect the sunrises, the sunsets, the moon, the clouds, and design the skin so that there's a deliberate intention to dumb down any applications of external decoration which would degrade the minimalist simplicity of this particular building. And that's all. Thanks. And,
We've got a couple of minutes. Everybody's got a pressing question out there from the audience. Don't be shy. I just have one question on the facade. If you've got to be so cautious with the silicon, just have someone in the factory, why don't you do a combination of mechanical and silicon fixing? It's obviously there's reasons you don't.
Yeah, that is obviously an option, and it depends on the project. At tender stage, we indicated a mechanical capture as an option. It's gone down the path of not having mechanical capture. You can have the mechanical capture on vertical 2 sides, you can have it on 4 sides, but at this stage it's pure structural silicon attachment.
No other questions, guys? Got one?
No, you showed a slide towards the beginning which seemed to indicate there was staged opening of the building. Is that correct?
Yes.
Can you explain that a little bit more?
Well, in most tall buildings, they're designed as separate buildings vertically, and obviously settlement periods, settlement in terms of paying money over, paying for your unit. No building can substantiate settlement right at the end. You have to design buildings to settle. Even trigger bottom on these towers has done the same thing. It's basically, it's tried and tested way of developing a tall building.
All right, might invite Brett Taylor up for the vote of thanks.
Thanks, John. Borders and Water have been around for 50 years in southeast Queensland and have continually seen the change in the tall buildings and the skyline of Brisbane. So it's been great to sponsor today's event to see another building that's going to keep changing the skyline of Brisbane. So I'd like everyone to join me to thank the 3 speakers for a very great presentation this morning. Thank you.
Look at that, almost bang on time. Hey? That's always good. So thanks again for coming, everybody. We'll look out for that flyer for the 1st of September, and hopefully we'll see you all again then. Thank you, guys.